This is video help for problem 10.5, which is fairly short. I thought what would help you most of all, because I've already given you some answers in the homework written hints to check against, and it's probably fairly straightforward. The formulas are given in the text. But remember where all this came from. This is just spherical coordinates. Remember, for spherical coordinates for position r, r sine theta, cosine phi, and so forth. Well, this is just the same for that. And if G0 is my magnitude, sort of like the R magnitude there, I've got G0 sine capital theta and cosine capital phi, where capital theta is that polar angle between the z-axis and my gradient vector. And if I drop a perpendicular down to the xy plane, that line of that point in the xy plane, that has an azimuthal angle of phi. It's the polar angle for the xy plane. And you know how to calculate these angles if you were given these components. You see if you could take the magnitude here in the xy plane, that sort of g perp, that magnitude is just g0 sine of capital theta. The component along z is g0 cosine theta. So tangent theta would be that guy divided by g0z. Well, that guy is just, right triangle, g0x squared plus g0y squared over g0z. And then tangent phi, this guy is just g0x over g0y. If you take this g0x and you divide it, oh, you know what I want to do here? I want to call this y and that x to get tangent phi. This divided by that. So that's where the formulas came from. The only other thing I'll say is assume g0x is positive for this. And when you're drawing your pictures or getting your angles, there's one thing that you always have to do. You can't just use these formulas because they have ambiguities. They're usually two different quadrants that give you the same tangent. Well, what you do is go back to the original x, y, and z components to find out which quadrant you're in. Which of those quadrants is the right one.